Most frequent even element. Given an integer array nums, return the most frequent even element. If there is a tie, return the smallest one. If there is no such element, return negative num. Most frequent, right? So 0, 2, 2, 4, 4. Answer will be 2. This, and that. Okay. Uh, this should be max, I believe so. Use example test cases, run code. So I'm going for value in nums. If value modulo 2 is value, this is happening. There's hash map of value plus equivalent to 1. And then if value is equivalent to that max value, answer dot append key. Then I'm saying answer dot sort return answer of 0. Runtime error max argument is an empty sequence. Yeah, this one is empty, right? So I get it. So it could be a thing that there is no even element, right? One. I think so. That should be it. So run code 2 4 minus 1. Run. Submit this. Accepted. Optimal partitioning of a string. In this case, I can have AB, then AC, then AB, then A. So 4 of them. In this case, I can have 1, 2, 3, 4, 5, 6. Sliding window. Sliding window can be used. Left pointer is at 0, right pointer is at 0, while right is less than the length of S. I'll do some operations. This is my sliding hash map. Sliding hash map. So I will simply say something like this: sliding And here I'll say key, or this could be a set itself, because that will make a lot of sense. Here I'll say that okay, if s of right not in sliding, which means it's not there, so simply put it in. So also the number of partitions will be the answer, right? So answer 0 at the beginning. So if s of right not in sliding, then I say that okay, sliding dot add s of right. Let's say that as current element. Oh no, that will be absolutely fine. Sliding dot add s of right, right? And then I say that okay, let's move right forward. Else it's there, so I will say that okay, um, why don't I remove it, right? While s of right in sliding, then I say that okay, sliding dot remove s of left, and then I increase the left pointer by one step forward. And I think so that should be pretty much it, or no? Yeah. End of the day, I have to increase this again. Right? I can return my answer. By the way, where is my answer going to update? So let's say 1, then 2, then 3. Then I know it's not in sliding. It means answer plus equivalent to 1. Maybe. Not sure though. Use the example test cases, run the code. We have a 3, 3, which is wrong, right? So I think so. A, B was taken into 1. So if A is not in sliding, then put it there. Correct. Right increases. Now right is at B. Now, so right is at B. Now I say that okay. B not in there, so sliding dot add that stuff. So B gets in there. Now it's at A. So again, A not in sliding. No, it is there. A is there in sliding. So answer becomes 1. While S of right in sliding. While A is in sliding, sliding dot remove. A removed. Left increases by 1. While this is just in sliding, no, it's no more there in sliding. So I get out of that, and then I say that okay, मैं तो अभी भी A पे ही रहूँगा, right? End of the day, I have to add this. Done. Answer should be 4 and 6. 3 and 5. Acha, I think so. This will be initialized with 1 if I'm not mistaken. So now this will be definitely 4 and 6. But what if this was this? Then this should be giving me 1, right? Correct. What if this is A, B, C, D, E, F? This should give me 1. My bad. Run the code. This should give me 1. Great. Let's submit this. We have a wrong answer. My output is 3, but they expected 2, right? Okay, so S, H, K, Q, B, Y, U, T, D, V is in one segment. And then I guess all of these guys are in one segment. Acha, what was happening in that case when we had something like use example test cases, when we had this thing, then why do I need to do answer is 1? Why do I need to do that? Let's see. Run the code. Answer is 3 because answer increases there once when I'm at A. So right now the sliding has only oh okay. Okay, substring में divide करना है, right? So if that's the case now, I'll say that okay, let's remove all of it till that. So while left is less than right, let's just do that. Or I can say that sliding is initialized to empty. Sliding dot add this, and I'll say also that sliding gets initialized to empty, and then I also say that my left is coming at right. Do I also need the left? No, I don't need the left. I can probably ignore left here. So when I'm at AB, right? So A is not in sliding, put it there. B is not in sliding, put it there. A is in sliding, so answer increases by 1. Sliding becomes empty, then I add A again, then right goes forward. Yeah, so this should give me 4 right now. This is again A1, right? Hmm. This is 4, but I had this test case which is going to give me 2, right? Let's see. Now this is giving me a value of 1. Okay, where am I going wrong here? Mm, mm, mm. Okay, better thing to do would be just take this and Acha, okay. So if I run this, this is going to give me 1. Yeah, which is wrong because let's say this segmental, I guess this k, right, is going to be that one substring. So whenever I encounter this k, I know I have to change my position. So answer definitely increases by 1. Definitely answer increases by 1. But I also initialize this as this sliding dot at this and then right plus equivalent 1. Okay, so whenever in this segment I know that my right becomes length of s, I say answer plus equivalent to 1. That should be it, right? Yeah, this should give me 2 right now. And example test cases would be fine as well. Use example test cases, run code. This is 4 and 6. 3 and 5. Again, it's a wrong thing, right? Okay, again, let's say 3 and 5 is something I'm getting. So AB is in one segment, answer increases, then right also increases, correct? Yes. So right now I have again A, and then again I get C into the then sliding. Yeah, C goes in there. Oh, of S minus 1, I guess. Length of S minus 1 or length of S? Hmm. Then A and C will come in, right? So C comes in there. Again, I know that A is already there, so answer becomes plus 1. So answer is right now 2. Then A comes in, B comes in there. Answer becomes plus that value. So yeah, makes sense. So this thing should be, I think so, not only here, but here as well, or no? Or should I initialize this as 1 and then begin the entire thing over again? So this is 4 and 6, no problem. But what about this again? Should be 2. Okay, let's submit this. Accept it. Why did I take a lot of time there? So divide intervals into minimum number of groups. Let's see. Divide intervals into minimum number of groups. You are given a 2D integer array intervals. You are given a 2D integer array intervals where intervals of I is left of I, comma right of I. Represents the inclusive interval left of I and right. So if it's 1 and 5, then I know it's 1, 2, 3, 4, 5. Inclusive, right? You have to divide the intervals into one or more groups. You have to divide the intervals into one or more groups such that each interval is exactly in one group. Yes. And no two intervals that are in the same group intersect each other. So it's like, let's say in one group I have intervals 1 to 4 and then 6 to 7. So that is fine because they are not intersecting. But I cannot have something like this. So So in, let's say this is one group. So over here I can have intervals, let's say 1 to 4 and then 6 to, let's say, 11, right? This is fine. But I cannot have something like 1 to 4 and then, let's say, 3 to 6, because that's intersecting. This is not allowed. Okay, this is live streaming correctly right now. And written the minimum number of groups you need to make. So probably in a group I'll try to put as many intervals as possible. Okay, two intervals intersect if there is at least one common number between them. Definitely. For example, the intervals 1, 5 and 5 will intersect. Definitely. Or this could be 4, so that's intersection again. Acha, so two intervals intersect if there is at least one common number between them. Acha, that is the definition. So 1, 5 and 4, 6, I think so don't intersect. What if I give the test case is like this instead of this? What if I give a test case like this? Just to see that what will be the answer. 5 to 10. Let's, instead of that I had 1 to 5, and then this is probably 5 to 8. So this should give me a value 2, right? I'll just write it on 2. And again, this is just to check that I'm going in the right direction. Oh, not available during contest. Okay. Anyways, get rid of that. Use example test cases and we'll see that. So in this case, it's 5, 10 and all of those things. So let's take this 5, 10, 6, 8. 5, 10, 6, 8, 1, 5, 2, 3, 1, 10. So maybe I can just sort this. So 1, 10 comes first, 2, 3 comes first. Sorry, 1, 5 will come first. This is done. 1, 10 is done. 2, 3 is done. I guess 5, 10, and then I guess 6 and 8. So let's get rid of the topmost one. So this is like a new sorted one. Yeah, this is a new sorted one. Oh my god. So this is my new sorted interval list array, let's say. So here I can say that, okay, how many groups do I need? So let's say in one of these groups I'll put in 1, 5 by default. I have to put it, right? I have to definitely put it. So 1, 5 is there in this group. Now what do we do? Now when I'm at 110, I know 110 is intersecting because 110 will be this, 1 will be same, right? So 110 is intersecting. I definitely can't have something like a 110 here. Maybe this could be a 2-pointer thing wherein I have to do that, but let's see, I'm not sure. So I know that, okay, when I have 1, 5, but it's better to go from the very end, right? Or let's say 1, 5, 110, I know that, okay, that is not possible. Not go n square, by the way. 2, 3 is possible here in this group. 5, 10 is not possible. 6, 8 is possible. So that's one group. So 1, 5, 2, 3, 6, 8 has been taken. In this case, I think so. Again, I have to form one group with 1, 10 and one more group with 5, 10. Answer will be what? 3. 3. See, 1, 5, 6, 8. 1, 5, 6, 8. Acha, so that also matters. Okay, so in here I can not have 2, 3. So 2, 3 can come up here. 2, 3. Okay, makes sense. 2, 3, 5, 10 can be in there. Yeah, 1, 10, and then this is going to happen. Okay. It can be proven that it is not possible to divide the intervals into fewer than 3 groups. For this one, again, I think so output is 1 because 1, 3, 5, 6, 8, 10, 11, 13 are not even intersecting each other. That's the answer. None of the intervals overlap, so we can put all of them in one group. What could be the way here? I know that if I'm at 1, 5, if I'm at 1, 5, I know I can have all the values in this group wherein my starting value of the next group would be greater than 5. So in this case, I simply do a search here and I see that, okay, 6, 8 is greater than 5. I put that in. That's it. Now when I'm at 110, again I have to look for all the values which are greater than this value 10, which is not there. So that's going to go in one group. When I'm at 2, 3, again I'll look forward to all the values that are greater than 3, which in this case is 5. So I'll put that 5 value in. That can be done. But the thing is, when I'm taking 6, 8, I will also make sure that from 1, 5, when I'm taking 6, 8, I'll also make sure keep. Acha, there could be a scenario like this, wherein I have 1, 3, then I had 4, 5, and then I had 5, 6, 7, 8. So here, if I simply go for this, then I can simply go for this one, and then this will be left in one row. Or I could even do this, go here and then go here. So this is left in one row. Can be done. I was thinking something with binary search, but I don't think so. That will make a lot of sense. So basically with binary search, what I was thinking is that once I am at picking a value into one group, then with this value, I'll binary search seal value of this, which is 4. So I pick this now in this group itself. Now here I will do a binary search with 5. I know this can be taken in, so that's taken. A binary search with 8, no, nothing else can be taken, so that should be it. Or I could try this key. Let's say for this test case itself, where is it? Okay, let's try for this itself. Instead of binary search, whenever I'm at a particular group, I'll put it in a thing. So in this case, it's 1, comma 3, and this could be a minimum heap, correct? Or this could be a max heap. That will make 100% of sense. Max heap. So I know 1, comma 3 is at the top. Whenever I encounter 4, comma 5, I'll check that, okay, is 4 greater than this 3? Yes, just put it there. So this will look like 4, comma 5 and 1, comma 3. Whenever at 5, 6, I know this is not possible. I put 5, 6 here. Oh, okay. Whenever 7 hit. So, okay. This 7, 8 can be put in at any one of these, right? I guess. If I'm not wrong. The 7, 8 could be put in this value as well. So it could be put in here. So this will become 7, 8 and then followed by 4, 5. So there are two possibilities now. एक तो top में था 4, 5 and एक top में था 5, 6. If there are two possibilities for 7, 8, what will I do? 7, 8, right? So this 7 should be after this 5, right? After this 5 and 6. So I know the 7, 8 could be put in here as well or could be put in here as well. I think so better would be to put into the smallest one, right? So that for this one I can accommodate later stuff. Yeah, better to put in here. That will be optimal. I think so I need to simply find in the seal value, or let's say the floor value in this segment, I guess. Floor value will be what? 5 itself. That's it. Our floor value will be 6, right? Not this thing. So my condition could be as follows, that okay, if the current number, while binary search, my condition could be that okay, if my current number is at 6, If 6 is less than 7, then this could be one of the answers. Answer is mid, but I also go end is equivalent to mid minus 1. Correct. Okay. So I'm looking forward to finding smallest y such that y is less than the current number x. And if I don't seem to find it, if the value is -1, I know I have to create one more group. That's it. So in this case, where is it? In this case, 5, 10, 6, 8, 1, 5. So let's say 5, 10, 6, 8, 1, 5. So I guess 1, 5, 1, 10. 2, 3 was there. Yeah. 5, 10 and 6, 8 is there. So in here I can maybe say that, okay, can this be done using stack, by the way? Not pretty much sure, but let's say 1 comma 5 is there, and then 110, since this is not kind of valid, so 110 automatically gets put in. 2, 3, so again, then 5, 10. Okay, 5, 10 kind of matches this, so I get rid of both of them. I think so. I get rid of 2, 3 and 5, 10 follows. Then 6, 8. No, it's not there. This could be a way, but no, it's not the way. There could be a lot of variations to this. Okay, anyways, so I'm at, I guess, 1, 5, 1, 10, 2, 3, 5, 10, 6, 8. So at 1, 5, I create one group, so that's 1, 5. 1, 10, I know that if I do a finite search at 1, I don't seem to find any interesting value, because yeah, I don't seem to find any interesting value. 1 से कौन है यहाँ पे छोटा? No, there's nothing as such. So that's going to be one more group with 110. There's nothing but groups. Now with 2, 3, I seem to find 2 se chota value will be again none. So 2, 3 comes in one of these. Now with 5, 10, with 5, the smallest value here is which one? 2, right? So 5, 10 comes up here. So again 5, 10, when it comes up here, it gets adjusted like this: 5, 10, and then 2, 3. It's a kya bolte hain, tree kind of a thing. Then 6, 8, right? So 6, 8, 6, right? So smallest value for 6, this one, 6, 8 comes up here. That's why 1, 5 and 6, 8 are together, right? 1, 5, 6, 8 are together. Then 2, 3 and 5, 10 are together. Where is it? This one. And then 110 is alone, right? 110 is alone, if I'm not wrong. Yeah, 110 is alone. This could be done. So let's just do that. Before I probably begin, I'll say info heap, and then let's say my groups looks like an empty array. My groups is an empty array. So I simply loop over the interval. So for I in range length of intervals, what's my start and end point? Nothing but intervals of I, that's tuple unpacking. 641 it is. Okay, so start and end is intervals of I, and now I'll say key. Let's by the way, if not groups, it means it's generally empty. So I'll say key my new it. Okay, so in my groups I'll do something like this: groups, or let's say A is going to be nothing but intervals of I. How is the intervals given? Okay, it's a list of lists, right? So groups dot append A. That's it. Or do I need to even do that? And say okay. Groups dot append intervals of I. Done. Else it means that okay, right now I don't know how many groups are there. I mean, I know key there is some value in groups, so let's find it, right? So let's find the correct position. And again, this is going to be value, right, which is probably this thing. Dot push in my heap. Again, this is like a max heap, so there's nothing but a max heap. It's very important to note this. Inside of this, I'll put in the value in this format, by the way. So I want this 6 8 to be at the top, right? So if 1 comma 5 is there and 6 8 is there, so I want this to be at the top. So this could be a minus of 6 comma 8 and then minus of 6 8 and then minus of 1 5. That's it. Would be like this. So I can say minus, let's say minus of intervals of maybe minus start comma minus end. That's it. So probably right now, correct. Minus of start and minus of end makes a lot of sense, hell lot of sense. So that's done. So groups dot append heap. That's it. So in the heap, I've posted in that value, and then I'm saying that okay, groups dot append heap. Let's find the correct position right now. Okay. So in order to find the correct position, I'll say that okay, my position could be -1 because this says that okay, I have not yet found the position. My start will be 0, my end will be length of groups. My groups -1. Also, this start and end could be reiterated as what do we say? I and j. That's it. I don't want to. Okay. Start idx, and this is, or maybe I can have simply s and e. Because start and end is something I've taken here, right? That's why I'm not taking here. So here itself I'll say that okay, while s is less than equivalent to e, in that case my mid is s plus e minus s by 2. Classic stuff. Why we do this we also know. Now in this case my groups is going to be containing the values in this way, right? So probably let's say -1 -5 and then so on it will contain. So let's say my mid arrives at some point, this point here. So what will I compare it with? I'll compare it with start, right? So I want my start. I need to find the smallest y such that y is less than the current start. So this is x and y, right? This is x and y. So what's my y value? It's nothing but groups of mid of, so when I'm saying groups of mid, I'm referring to that entire part. Groups of mid of 1, and refers to that y part, and that negative kind of helps me. So if y is less than probably whatever my start value is, in that case I say that okay, hey, this could be one of the positions, but I also need to find a better position. So e is going to be mid -1. Else I say that okay, let's move forward and try to find the position. So again, if position is equivalent to -1, yeah, if position is equivalent to -1, in that case I'm hoping to do so key if position is equivalent to -1, I'll put in the value in this way itself again. So let's just copy this stuff and paste it here itself. Else I know that okay, we have a valid position. That's great. So at that position I'll put it in, right? How will that look like? That will look something like this, that okay, groups heap q, by the way, heap q dot heap push in the groups of position, right? In the groups of that position I'll put in which value? I'll put in this value, which is minus of start and minus of end. I think so that should be pretty much it. End of the day I have to return the length of the, again I know there could be a little bit here and there, problems here and there. So let's try to run this stuff and see where we have a problem. List index out of range, right? Groups of mid. Okay, let me see real quick. Length of groups. Here is this. As this mid. This should be S. This should be S. No, start is fine, I guess. Huh? S is mid plus one, and then this is going to follow. Minus of groups of mid is problematic. Start plus end minus start by 2. That's what we do, right? And then start append heap. As groups of mid is referring to the entire heap and of 0 of 1. Yes. I missed out on this. So, correct. Now this could be fine because right now, yeah, 5 and 1. But 1 is fine. Why am I getting 5 for this? Let's see. Okay, I have not sorted it, I believe so. Yes, I have to sort it. So this would be intervals dot sort at the very beginning because it's pretty much needed. So let's just do this. Run code. So we have a 4 and 1, which in this case is again wrong. Okay. पहला वाला को थोड़ा देख लेना पड़ेगा, better रहेगा. Okay, let's see now. First one, let's see this. What's happening here? Let's quickly see this. Let's put that and then remove this. Remove all of that and that. So this is M, this is S. And I'll call this thing S and M, right? And the list is provided. S dot M, and then probably that list will come in here. Where is this one? List of lists. Okay, answer is 4, but why is it 4? Let's see. So intervals dot sort. So what was the interval looking like? 1 5, 1 10, beautiful. 2 3, 5 10, 6 8. Yeah, as expected. So let's just see. If not groups, then definitely I put inside of my groups. Yeah, groups gets initialized with -1 and -5. Beautiful. Then we have else part, wherein again I think so. This will conclude to group being at groups dot append heap. So again my group got added one more element, right? Yeah. Done. Now again next, and then if not groups, heap is this. So position is -1, definitely. Position is S is 0, E is length of this, and then E becomes 1. Beautiful. While S is equal to this, I think so. Again, in this case, 1 5, 1 10, and then we had 2 3, right? So 2 3 will again go into a separate group, if I'm not mistaken. Yeah, 2 3 goes into a separate group. So group looks like this. Correct. 1 minus 1, minus 10, minus 2, minus 3. Done. Now, for I is this. So right now I'm at what? 2 3 के बाद क्या था? 2 3 के बाद आएगा 5 10. So 5 10 can be put after 2 3, right? What's happening there then? 5 3 5 10 can be put after 2 3. Let's see. In groups of position, place in this value. So I guess 2 3 में ये आएगा, right? Next की है तो कहाँ पे गया? Beautiful. इसी में गया. -1, -5, -10, right? So this is at the top as well. That makes 100% of the sense. 2 3 and 5 10 are at the same group, right? 2 3 and 5 10. Yeah. And this 6 8 should go to 1 5, right? But it's not going. Let's see. 6 8 should go to 1 5 then. Why is it not going? So currently start and end is 6 8. Beautiful. So I need 6 to be greater than any one of these. So in this case 6 is greater than 5, right? So it should give me a proper value, but it's not, right? Let's say position is -1, S is 0 is this, this is this, mid is 1. So this is never going to give me something. Uh, so S becomes 2, right? Okay, I never go into that segment. Hmm. Every single step I need to do groups dot sort, I believe so. Astro. It's going to sort the entire representation, right? Now if I tend to run this, if I do a groups dot sort here as well, visualize should give me, again it's giving me 4, which is not wrong. I mean not right. Okay, groups dot sort reverse equal to true. Then should give me 3 or no? Again it's 4. Oh my god. Okay, let's see for the very first few ones. Then when this comes up, right? Negative to negative 3 makes sense. Then I guess 6 and 8 will come up. Let me see. Yeah, so 5 and 10 comes up. So when 510 comes up there, I think so. Am I? Yeah, that gets sorted again. Then we begin the process. Current value is what? Okay, let's do from the beginning. Mid is going to be actually 1. So at the 1th location, I see the value is 10. So if the current value y, अच्छा मेरा start है let's say 100 and y है 50. So I need y to be much smaller. So if y is less than start, I say this thing will happen. Still 4. Can't get the thought behind this because that's 5, 10, and then it's not uniform, right? Then we have something like 3. So it's not uniform. Okay, here out of all the things, right? Kya kya hai? 1, 5, 1, 10. So we have something like 1, 5, 1, 10, and 2, 3, and 5, 10 are at the same spot. So that's 5, 10, and then 2, 3. इसमें how do I determine कि 6, 8 कहाँ जाएगा? So 6, 8 was going to go in this segment, right? And if this value is greater than that, then it goes beyond this. This is 5, 10 as well. This could be, by the way, 5, 3 as well, right? This could be 2, 1. So I mean 2, 2, 3, and this could be 5, 2, I guess 6. So this is not uniform, right? This 5, 10, and 6 is not uniform. Then on how basis, what basis am I comparing here? Is this a problem of longest increasing subsequence? Once I sort this, is this a problem of longest increasing subsequence? So how do I determine that this is longest increasing subsequence? It is not, right? So let's say 1, 5, from 1, 5, starting at 1, 5, the longest increasing subsequence would be probably 1, 5 is 1, and then followed by 6, 8. Starting from 1, 10, I think so. The answer would be none, because 110 is in itself. So this is in one group, this is in one group. Starting from 2, 3, longest increasing subsequence will be 5, 10 itself. I think so that should be it, because so let's say I start from 1, 5, then I loop over and then I see which one of them is see that 2, 3 is one of them. So I also need to get rid of that now. Not able to figure out here. Maybe I just need to simply go into the groups and see if that fits in there. Simply put in there. That should be pretty much it. That should wrap up the problem indeed. But the answer for groups could be a lot, right? It's 10 to the power 5, and this is this. Let's try this one then. You are given an integer array nums and an integer k. Find the longest subsequence of nums that meets the following requirements. The subsequence is strictly increasing, okay. The difference between adjacent elements in the subsequence is at most k. Done. Return the length of the longest subsequence that meets the requirements. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. That should be at most k, right? So k is 3, and to find the longest one. So in this case, if I start with 4, I can probably go to 8 and then 15. It's 3. But I could have started from 1, then I can get 4, then I can get 8, then I can get 15. That's one way. One more way would be probably, so 1, yeah, 1, 4, 8, 15, that's 4 elements. But what if I start from 2? So 2, 5, 8, 15. Okay, so it's 1, 3, okay. At most k. At most, okay. So 1 I can have 3 as well. Okay. But increasing as well. So I cannot have something like 2, 1. 1, 3, 4, 5, 8. Makes sense. Should be in that range. So this is difference is no more than 3. Difference is no more than 3. Difference is no more than 3. And then here as well, difference is no more than 3. The subsequence has a length of 5. The subsequence has a length of 5. Okay, so positive minus 87 is larger than that. In this case, again, we see the following stuff. What can be done here? So I can consider this as a part of my subsequence, or I won't consider this as a part of my subsequence. If I consider this, I'll compare it with the last element and then proceed. So it's more like this, that solve function call at index 0, and then nums is provided, and then k is also there. I'll also have something like a last element. In this case, it could be 0. So return result. So let's have the function define solve. I have the index, I have index I have nums, I have k, I have the last element. Last element, that's right. So let's think about the base case later on. What do I have? So I have the option to include the current number into the subsequence, or not include. So when can I include this number? So if nums of I is greater than, or I can say that, okay, nums of I minus the last number is, right, is probably less than equivalent to k. It means, okay, I can have it. So let's include it. That would look something like this. If I include, then the value is 0. If I don't include, so not include, the value is again 0. So if I include, then the value would look something like this: 1 plus a solve function call at I plus 1 nums followed by k followed by last number will be nums of I. That's that. And then if I don't include, that will be not include, will be, if I don't include this, that will be 0 plus solve function call at probably I plus 1. Nums will be as it is, k will be as it is, and last will be as it is. I have to return the maximum of what if I included and what if I not include. By the way, if I reach the very end, if I is equivalent to the length of nums, I know I'm at the very end, so return 0. I don't need to do stuff there. And looks pretty much good to me. Let's run this. 7, right? Which is wrong. Hmm. 3 minus 5. Uh, hmm. This should make a lot of sense then. Giving me 5, which is right. Use example test cases, run the code. Okay, run the code again. How much time is left though? 33 minutes left. It's giving me 5, 4, and 1, which is the correct answer. Now, if I try to submit this, I think so. This should be a TLE because I'm trying every single possibility. That's 2 to the power 10, 2 to the power 10 to the power 5, right? So uh, optimization could be that if at the current index, I'm at the value last. Yeah, could be an optimization. It's something like a DP. So let's say let's memorize the value. So what's my current state that okay, was I at the current index with the same last value? If that's the case, then see that okay, if the current state in DP, then return that value. Done. Else, if it's not there, then simply memorize the current state in the DP. So that would look something like this: DP of uh, current state is going to be a maximum of what if I include and what if I not include. Let's run the test cases again. Run code 541. Let's submit this. We have indeed a wrong answer because they expected 1. So I have to return the maximum of result and 1 because indeed end of the day that will makes a lot of sense. Submit. This might give me a TLE because last value could be different, right, for every single value. We have a wrong answer. What happened here? So 4, 5, right? And then 3 is there. So I initially pass in the value 0. Acha. So I can include if last is -1. I can include if last is -1. So right. So if let's say last is equal to -1 or all of this will happen. Let's submit it for this test case 453. So run the code. This should give me 2. Use example test cases. Run the code again just to make sure we are on the right page. Run code 541. Let's submit this. Okay, जब वो last is -1, I know कि I can start from there, right? Time not exceeded as expected. So not a problem. All the numbers are different as expected, and the value is one, right? I will end the stream right now. Continue later on.